How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss the nature of the roots of a quadratic equation by the use of discriminant. So, before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to our new session for the most essential learning competency, which is focused on Mathematics 9, Quarter 1, Week 2 to 3. For today's lesson, we're going to discuss all about the nature of the roots of a quadratic equation using the discriminant. Now, this lesson will be given for a quadratic equation and for us to determine the nature of the roots. So that is our objective for this discussion, to know the nature of the roots given the quadratic equation by the use of discriminant. So the question is, what is a discriminant? The discriminant is the expression b squared minus 4ac. Now, if you could still remember, this expression b squared minus 4ac is quite familiar in our previous topics in Mathematics 9, which is about the quadratic formula. The value of the discriminant can be used to determine the number and types of roots of a quadratic equation. So, when we say nature of the roots, it means that we are not trying to solve the value of the roots or the roots itself of a quadratic equation. Instead, we are knowing the nature or the characteristics of the roots, whether they are real or not real, whether they are rational or irrational, or whether they are equal or unequal. Okay, so now let us continue. How have we previously used the discriminant? We use the discriminant to determine whether a quadratic polynomial could be factored. If the value of the discriminant for a quadratic polynomial is a perfect square, meaning it has a square root that is a whole number, the polynomial can be factored. Now, if you could still take a good look or recall our discussion for solving quadratic equations, we have the method factoring. We have the method extracting square roots, we have the completing the square, and we have the quadratic formula. By the use of the discriminant, that b squared minus 4ac, we can now determine exactly whether we have an equation or a quadratic polynomial that can be factored. Now let's try to solve this given equations. We have for number 1, x squared minus 5x minus 14 equals 0. We have 2x squared plus x minus 5 equals 0. We have x squared minus 10x plus 25 equals 0. And finally, we have 4x squared minus 9x plus 7 is equal to 0. Now, we will use the quadratic formula to solve each of the following equations. Let's evaluate the first equation. Given x squared minus 5x minus 14 equals 0. What number is under the radical when simplified? Now, remember, in our quadratic formula, we have x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. The expression inside the radical sign or symbol is the b squared minus 4ac. Now, let us try to evaluate that by the given values of our a, b, and c from our quadratic equation, and that is 81 or positive 81. Now, positive 81 is a perfect square, right? Okay. Therefore, we can say that this kind of equation can be used in factoring. Now, if we try to continue our solution in the quadratic formula, the values for our x or the roots will be negative 2 and positive 7. Now, if you could observe, this value 81, this is from the radical sign, right? That is known as the discriminant. Remember these values. If the value of the discriminant is positive, the equation will have two real roots. Like our previous given, we have negative 2 and positive 7. In addition, if the value of the discriminant is a perfect square, like our value in the radical sign, 81, then the roots will be rational. So, our nature of the roots is real, rational, and unequal. Real because negative 2 and positive 7 are real numbers. They are also rational numbers. And as well as they are unequal because negative 2 is not equal to positive 7. But, let me remind you, my dear math learners, by just knowing the discriminant, even though you don't need to get the value of your roots, you can determine the nature of the roots. Then again, remember this, that if the discriminant is positive and is a perfect square, the nature of the roots are real, rational, and unequal. Okay, let's continue. Let's look at the second equation. We have 2x squared plus x minus 5 is equal to 0. What number is under the radical when simplified? Now, let's go back to the quadratic formula. Square root of b squared minus 4ac is the radical expression. And if we try to evaluate that, we will have the value of 41. Now, question, is 41 a positive number? Yes, it is a positive number. Therefore, we will have two real roots. However, is 41 a perfect square? Okay, no, because 41 doesn't have any root that is a positive whole number. Now, if we try to continue the solution for our equation using the quadratic formula, we will have a value of negative 1 plus minus square root of 41 all over 4. Now, this given value is an irrational number, or this answer is irrational, right? So, what can we conclude in this given scenario? If the value of the discriminant is positive, remember, this is just the same as earlier, you will have two real roots. But in addition, if the value of the discriminant is not a perfect square, then the roots will be irrational. So, for the nature of the roots, we can therefore conclude that the nature of the roots are real, irrational, and unequal. Easy, right? Okay, now let us go to the third example. X squared minus 10x plus 25 equals 0. If we use our radical part in the quadratic formula and we simplify it using evaluation, we will have a value of 0. Okay. Now, if we continue our solution, we will get a value, or the value of our roots of the given equation is 5, which is a double root. When we say double root, we have two values that are both the same, positive 5. Okay. Now, what can we say about this kind of scenario? If the value of your discriminant is 0, the equation will just have one real root. Okay. Unlike earlier, if it is positive, we have two real roots. But if the value of the discriminant is 0, you will only have one real root. And this will be a double root. And if the value of the discriminant is 0, the roots will be rational. Because as the earlier example, we have 5 as our double root and 5 is a rational value, right? Okay. And therefore, we can say that the nature of the roots are real, rational, and equal. Okay. So we already have discussed the three scenarios. So now, let us go to the fourth and final example. We have 4x squared minus 9x plus 7 is equal to 0. Now, if we try to solve the value in the radical sign, b squared minus 4ac, we have the value negative 31. Now, continuing our solution using quadratic formula, we have the final answer as 9 plus minus I, which means imaginary, square root of 31 all over 8. So this is a complex number. This is not a real number. So what can we say? So what can we conclude in this scenario? If the value of the discriminant is negative, the equation will have two complex roots. And they will be complex conjugates, meaning it is an opposite expression with an imaginary value and the sign is just different. But to make it easier for you guys, my math learners, we can just say that the nature of the roots is no real roots. Okay, now let's try to go further about how can this be useful in our succeeding lessons. Now, let's put it in a chart. Our lesson, let's put it in a chart. Now, as you can see here in the given, we have the first column as the value of the discriminant. We have the second column as the type and number of the roots. And the third is the graph of the related function. Remember that in the next preceding lessons, we will be talking about how to graph quadratic functions, but more about that on our next videos. So let's just consider this table. As you can see, if our discriminant is positive, meaning greater than 0, we have two scenarios. If it is perfect square, we have two real rational roots. If it is not perfect square, we have two real irrational roots. And the graph, our parabola, will touch the x-axis twice. This is the first and this is the second. Okay? That's a simple. Now, if our discriminant is equal to 0, we only have one real root. And the graph for that is that it will only touch the x-axis once. Okay, so you see the difference? And finally, if you have a value of negative, meaning the discriminant is less than 0, you will have two complex roots or no real roots. Therefore, our x-axis will not be touched. Okay? So, there will be no intersection on the x-axis because we don't have any values for our x. Okay? So, as you can see, by just looking at this graph, we can say that the value of x are twice, or there are two values of x. While in this second chart, we only have one value of x. While in this given chart, we have no values of x. Okay, I hope you have the clear idea about how to interpret the discriminant of a quadratic equation. Now, let us go to test whether you have understand our discussion for this session. We have here, for each of the following quadratic equations, find the value of the discriminant and describe the number and type of the roots. So we have here 4 given examples or 4 given problems. 1, 2, 3, and 4. So good luck in solving that one. And I also have another thing, which is this one. Okay, try this. This is quite a challenging part in which you will tend to get the value of the middle term for number 1. And for number 2, you will try to get the value of A. And number 3, you will tend to get the value, or you will just need to discuss whether this has two real roots. And if so, what is the product and what is the sum of these two solutions? Okay? So, I hope you have learned something about our discussion in the quadratic equation, which is focused on the nature of the roots by the use of discriminant. This is still your free access math teacher Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you, keep safe, and God bless always. Fellow math learners, if you think you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.